Hey, welcome back everybody. Gary Simmons here for the Game Institute with lesson 48 of the Dead Earth game development series. In the last lesson, we continue to add audio collection player scripts to many of Jill's locomotion states in both her base and lower body layer. And we also added audio collection player scripts to the attack states in her attack layer. The exception being Attack 2, which is Jill's feeding animation. And as we discussed in the last lesson, we're going to use an entirely different audio system for dealing with long playing or looping sounds. You will recall though that our audio collection player script uses our audio manager's one-shot audio system. It triggers sounds in response to commands coming in embedded in animation curves in the animation that is playing in that state. The great thing about the one-shot audio system is it is very much a fire and forget system. When we wish to play a sound, we just request that the audio manager play it and it will utilize an audio source from its pool of audio sources, position that audio source in the world and play the sound. That sound has no comprehension of any other sounds that are playing. And that's a really cool feature for things such as our footstep sounds, where even if our zombie is running very quickly and we're having lots of footstep sounds fired very close together, it doesn't matter. Even if 3 footstep sounds are overlapping, 3 separate audio sources are being used, so that doesn't present a problem. Of course, the one-shot audio system is not the right fit for all situations, such as when we have long playing or looping audio, or if we have audio that needs to play for an indeterminate amount of time, such as our feeding animation where we wish the sound to play for as long as it takes for our zombie's satisfaction level to pass a certain threshold. And furthermore, because the one-shot audio system allows multiple sound requests to be launched that may overlap one another, it's also not a good choice for if we have a group of audio clips and we only ever want one of them to be playing and some of them to cancel each other out. Now, a classic example of this might be when we're in our base layer. Our zombie is going to be making what I call ambient sounds, right? It's going to be walking around the level doing things like that. We're going to create an audio collection that just has lots of these types of sounds in, and we just want these sounds to loop forever while the zombie is investigating the level. So when we're in idle, we'll be doing something like and we'll probably be playing those same sounds when we're walking as well. But when we're jogging or sprinting, we may want to play a different sound, such as and perhaps when we're turning left or right, when we're seeking a target, we want to have something like So we first of all want a system that doesn't really fit in with our one-shot audio system, because the one-shot audio system kind of carries on playing till the end of the audio clip, whereas in this particular case, if we were going in our walk state, even if we were only halfway through the audio clip's timeline, if we were then to transition into the zombie turn left, we would want that sound to stop playing and immediately this sound to play instead. But of course, it's even more complicated than that because we have multiple layers. So let's say, for example, on our base layer, we are in our idle state and we are playing a sound such as and that sound is just looping around endlessly while our zombie is in the idle state. Then, let's say the zombie sees us and decides to scream. Well, then we want a screaming sound to play, and we want that to override and block out the sound that is being played on the base layer. A little bit like our layer exclusions in our audio collection player script, but slightly more advanced, and I'll show you why. So let's now say that we're now screaming, and then we get hit mid-scream. Well, then we're going to want to play a hit sound, such as the zombie going, ah! And then when that hit sound is over, we want the screaming sound to carry on playing for however long there was left. And then when the screaming's over, it falls back to the base layer, and we want the sound that was playing on the base layer to resume playing again. Preferably not from the place it left off, but from where it would be in its timeline had it been playing all along. So what we're going to do to combat this is we're going to create a new class, not a behavior, and it's going to be called the layered audio source class. We're going to give every one of our zombies its own dedicated audio source on its game object, and then our AI state machine will create an instance of our layered audio source class to manage that single audio source. The audio source will have a layering system. When we request it play a sound, we tell it which layer we would like that sound assigned to. higher layers will take priority and will commandeer the single audio source. So from Zombie Jill's idle state on the base layer, if we were to make a request to her layered audio source to play a sound, we would say, we want you to play this sound on layer 0. Because it has no other layers at the moment, layer 0 is the highest layer, and it would assign that audio clip to the audio source. But then, if we decided that we wanted Jill to scream, this state would then make a request to play a screaming sound, and in this case it would be on layer 0, 1, 2, 3, 4, right? Now each frame, our layered audio source will have an update function where it will check through its layers to see what the highest layer is, and if its highest layer isn't currently the layer that has its audio clip assigned to the audio source, then it will make that change. So in this particular case, it would say, hey, we have a new audio layer now that is higher than our base layer, and therefore we need to remove the clip we currently have assigned to that single audio source and assign the screaming audio clip to that audio source instead. If while that sound is playing, we then make a request to play a hit sound, the same thing will happen. In the next update, the layered audio source will recognize that there is now a new layer that is playing that is higher than the current layer that has its clip assigned to the audio source, and it will make that change, now assigning the hit audio clip to the audio source instead of the screaming clip. But what our layered audio source will do in its update function is it will keep updating the timelines of all layers, not just the layer that currently has its audio clip assigned to the audio source. This means that once the hit sound has reached its duration and is no longer playing, the layer will become inactive, and our audio source in its update function will now find that the interactive layer is now the highest layer, reassigning the screaming audio clip back to the audio source. But because it's kept track internally of the interactive layer's timeline, the screaming sound will not start from the beginning, but will carry on from where it would be had it been playing all the time. And of course, once the screaming sound has reached its duration, that will become an inactive layer, and in the next update function, the base layer's audio clip will be reassigned back to the audio source, but once again it will resume playing from the correct place as if it had been playing all along, because even when this layer didn't have the focus of the audio source, its internal clock was still being updated. The great thing about our layered audio source class updating the internal clocks of each layer, even those that don't have the focus of the audio source currently, is that we can use it in other situations. Like we could use our layered audio source class, for example, to model the sound of a television set. And on the base layer of that object, we might have the sound of a news reporter saying, "Breaking news just in, zombies have attacked the city," right? But then on another layer above it, we could periodically interject in white noise and static and things like to override it. But because the base layer is having its clock continually increased, when that static stops playing, when it goes back to the layer underneath it, the news reporter won't have paused. He will be in the correct place in its timeline as if it had been playing all along. So now you know what it is we're going to create. Let's be about it. So I'm going to drill down into my scripts folder, into my audio folder, inside my scripts folder, and I'm going to create a new C# script, and I'm going to call this layered audio source, like so. I'm then going to open it up in MonoDevelop. Our layered audio source is not going to be a component. It's just going to be a helper class, so it's not going to be derived from MonoBehavior. And therefore, we'll also for now remove the start and update functions. So the first member variable we're going to need in this class is going to be the audio source itself that it's going to manage. So we'll create a private audio source member called audio source with an underscore, and we'll set this to null by default because this is something we're going to pass in to the constructor of the layered audio source class. Also, we'll create a property so that we can inquire about which audio source is currently being managed by this layered audio source object. We're also going to need some support structure or object that's going to allow us to keep certain information about each of the layers. So what we'll do is we'll create a list of audio layer objects that I've called audio layers. Let's just create this support class up above. Just a public class called audio layer. Doesn't need to be serialized. This is only going to be used at runtime. And we'll come back in a minute and we'll fill out all of the members of the audio layer class. And just know for now that the audio layer class is going to contain the status of a single layer in our layered audio source. So it's going to contain things such as which audio collection it's been assigned and which bank in that audio collection it is to use. And also it's going to contain the current clip that it is playing from that audio collection, and also things such as the duration of the clip and also the current time of the layer, so we can detect when it reaches the end of the clip. And if this is a looping layer, then we know it's time to select another clip from the audio collection that it's been assigned. But we'll come back and fill all this stuff out in a moment. So we now have a list of audio layers, and finally we'll add a private integer which is going to allow us to keep track of the currently active layer. That's the layer that currently has its clip assigned to our audio source. So let's now go up and add the members to our audio layer. The layer is going to need to keep track of what clip it is currently playing. If this is the active layer, then this is the clip that will currently be assigned to our audio source. As with the rest of our audio system, our layered audio source is designed to work with audio collections, not single clips. When we tell our layered audio source to play a sound, we will pass it a collection and a bank. The layered audio source will then randomly select a clip from that bank. This brings us to an important point, such as when we wish a layer to endlessly loop. When we set one of our layers to loop, it doesn't necessarily mean we're just looping the same clip over and over again. We're looping the audio collection over and over again. That means once the current clip has reached its duration, we select another clip from the audio collection and start playing that one instead. Of course, if you wanted to mimic a single clip that was playing over and over again, you would just pass it a collection and a bank with a single clip in it. What's really great about this is for our idle animation, for example, on the base layer, we can pass in an audio collection that contains various zombie groaning and growling sounds. And if we set the layer to loop, then it will keep playing that audio collection endlessly, but each time selecting a random clip so that we don't hear that repetitive pattern. The next thing that our audio layer is going to need is a boolean that says whether this is a looping layer or not. As I've just discussed, a looping audio layer is not the same as a looping clip. If the looping boolean is set to true, once the current audio clip has reached its duration, a new clip will be selected from its assigned audio collection. We're also going to need a float called time, which is going to keep track of the current time of the layer, and another float called duration that will store the duration of the current clip that has been assigned to this layer. We know that each update, as we update time by adding onto it time.delta time, when time surpasses duration, we know it's time, if it's a looping layer, to select a new clip from our audio collection. Of course, if the looping boolean is set to false, a new clip won't be selected and the layer will be deactivated. Finally, I'm going to add a boolean called muted that will allow us to mute any individual layer, and also support a function that allows us to mute all of the layers if we so wish. So that is the complete audio layer class done. As you can see, it's just a data container that's going to contain information about the current state of each layer that is being managed by our layered audio source. Okay, so let's now write the constructor for our layered audio source class. It's going to take two parameters. The first is the audio source component that we wish this layered audio source object to manage, and the second is the number of layers we wish to have managed for this layered audio source. So as I said, I'm going to give each of our zombies an audio source, and what we're going to do in our AI State Machine startup function is we're going to fetch the audio source component, and then we're going to allocate a new layered audio source, passing in a reference to that audio source and the number of layers that we wish it to have. And of course, that's going to be retrieved from our animator, so that once we have the number of layers in our animator, we'll have a layered audio source that corresponds with that number of layers. And assuming we haven't been passed a null audio source reference, and assuming we've passed in a layer count that is larger than 0, well then we will store that audio source reference we've been passed into our private class variable. So now we need to set up a for loop that's going to iterate through the correct number of layers, and in each iteration of the loop we're going to create a new audio layer, initialize it, and add it to our audio layers list. So inside the loop, we create a new audio layer object. And of course, by default, we really just want to set all of these properties to 0 or null. So we'll set the collection of that layer to null. We'll set the duration to 0 because it hasn't been assigned a clip yet. We'll set the current time of the layer to 0. We'll set it by default to be a non-looping layer. And of course, we'll also set the bank to 0, and we'll set muted to false. And we'll set the audio clip that is currently assigned to this layer to null also. You're going to see later it's the update function that really checks layers and assigns clips and fetches clips from the collection that has been assigned to that layer. So everything really happens inside the update function. And finally, we'll add that layer to our layers list so that when this for loop is finished executing, let's say for example we requested 8 layers, our audio layers list will contain 8 audio layer objects, one for each layer. Next up, we're going to create the play function. This is the function that any external object can use to tell this layered audio source to play a sound. As you can see, it takes a number of parameters. The first is the audio collection we would like it to select a clip from. Second is an integer describing the bank in that audio collection that we wish it to use. Thirdly, we pass in the integer index of the layer that we would like this sound to be played on. And finally, we pass in a boolean describing whether this is to be a looping layer or not. As just discussed, the play function doesn't really do a lot. It just sets up a few variables so that in the next update function, all of this stuff can actually kick in and actually happen. So what we do is we just check that the layer that's been passed in isn't larger than the number of audio layers that we have in our layers list. And if that's true, we simply return false because we've passed in a bogus layer index. But assuming the layer index is valid, then we fetch the audio layer from our layers list. And next up, we want to check that the parameters that we've passed in doesn't describe exactly the current status of the layer as it is now. So if we pass in the same audio collection, the same bank, the same layer, and the same looping status that this layer currently has, then it's already doing what we want it to do. And this is a no-op we just returned from the function. So I'm going to say if the audio layer's current collection equals the collection that we've passed in, and if the audio layer's looping property is equal to the looping property that we pass in, and if the bank that we've passed is also equal to the bank that is currently assigned to this layer, then we just return true. There is nothing else to do here. Our audio layer is already playing a sound from that collection, from that bank, using that looping property, and therefore we don't need to set anything up. It's already doing it. However, assuming that's not the case, this is considered to be a new request, so we need to copy over all of the parameters that were passed in and store them in the relevant layer that we've just fetched from our audio layers list. So we'll copy over the audio collection reference, the number of the bank we wish to use from that collection, and also we'll store whether this needs to be a looping layer or not. Next up, we'll pass the time of the layer to 0 because we're just about to start playing a new audio collection. And we'll also set the duration to 0 because, well, we haven't selected a clip yet. We're going to do that in the update function. But by setting it to 0 here, it allows us in our update function, as you will see in a minute, to identify that this is a new play request and to assign a clip. And that will make a lot more sense in a moment when we see the update function. And next up, we set the muted boolean to false. Now this is just a design decision that I made so that even if a layer was muted, if we make a new play request to that layer, it unmutes it. Finally, we set the clip to null. Now you may think that in the play function, we would get a new clip from our collection and assign it to the clip, but we actually do that in the update function, as you'll see in a moment, and that just helps keep everything compact. Okay, so we've now configured the layer with the collection we wish it to use, the bank we wish it to use. Now we're going to return true. And in the update function, we're going to check this information and we'll know that we have to make a new sound assignment to this audio layer's clip, set its duration, and things like that. But we're going to look at the update function last. I'm just going to create a few other functions first of all, which are very simple. The next one is the stop function that allows us to tell the layered audio source to stop playing the sound on any layer. So as you can see, it's called stop. It takes a integer layer index. So inside the function, the first thing we'll do is we'll just check that the layer index is within bounds. Assuming it is a valid layer index, we will fetch that layer from our audio layers list. And assuming it's not null, which it should never be, we'll just set looping to false and we'll set the layer's time equal to the layer's duration. Now, this is going to make more sense in a moment when we look at the update function because it's the update function that's going to actually deactivate a layer. And one of the ways it's going to do that is it's going to increment the layer's time, and if it finds that the time is larger than the duration and it's not a looping sound, well then it's going to deactivate the layer. So what the stop function does is it says even if this was a looping layer, we're now going to set it not to be a looping layer, and we're going to set the time equal to the current duration of the clip that's playing on this layer. And then of course when we go into the update function, one of the first things that's going to happen is layer time is going to be incremented by time.delta time, and then in the update function when we test that time is now larger than duration, it's going to say, okay, is it time to play a new clip if it's a looping layer, or is it time to just deactivate the layer? And because we've set the looping boolean to false for this layer now, it's going to deactivate the layer. Next up, I'll create the mute function. We pass in the integer layer index and a boolean which describes whether we wish to mute or unmute the layer. So once again, I'll check that the layer index is within bounds of the layers in our audio layers list. I'll fetch the layer from the audio layers list, and assuming the layer isn't null, we'll simply set the muted field of that layer to whatever we pass in, true or false. And once again, you're going to see in a moment that it's in the update function that we actually react to the muted state of a layer. Next up, I'll create another function that's going to allow us to mute all of the layers of the layered audio source. And really, this is just going to call the function we've just created once for each layer. So it takes a single parameter, whether we wish to mute or unmute all of the layers in our audio source. And we'll set up an integer to loop through each layer in our audio layers list. And then we'll just call that mute function that we wrote above, passing in the index of the layer and whether we wish it to be muted or not. Now I've just noticed actually that when I do those layer tests in both the mute and the stop function, that should be if layer index is larger or equal to audio layers count, not just larger than. Okay, that should fix that. Okay, so what we'll do now is we'll work on the update function where all of the magic happens. Okay, so at the top of our update function, we're going to declare two local variables that will allow us to keep track of when we need to assign a clip to our audio source. The first one is an integer called new active layer. This is set to -1 by default. And what we're going to do is we're going to basically start at the last layer in the list and work backwards through that list. We're trying to find the highest layer that has a audio collection assigned to it and should be playing. And of course, if that is larger than the currently active layer, which remember is also a member of our layered audio source class, well then we know we've found a new active layer and we need to get the audio clip from the collection assigned to that new active layer and then assign that clip to the audio source. The next local variable is kind of used in the same way. It's a boolean called refresh audio source, and this is going to be used to keep track of when the active layer hasn't changed, but the clip assigned to that layer may have reached its end, and therefore we've fetched the new clip from the audio collection. So we need to know that we need to refresh the actual audio source so that that new clip is assigned to it. So that's how these are going to be used in a moment. Next thing we're going to do is we're going to set up a for loop that's going to iterate through the layers in our audio layers list. And because we're trying to find the highest active layer, we're going to start from the end of our list, audio layers.count -1, and we're going to work backwards all the way back to 0. So we're processing our audio layers list in reverse order. Inside the loop, we're going to fetch the layer that we're currently processing, which in the first iteration will be the last layer in our audio layers list. And we're going to see if there's a collection assigned to it. If there isn't, then it means this layer isn't being used, so we skip on to the next iteration of the loop. However, if this layer does have a collection assigned to it, then it's currently active, so we increment the layer's time by time.delta time. Next up, we see if the layer time has exceeded the layer duration. Now, the layer duration is going to be set whenever a clip is assigned to a layer, and that's going to be the duration of the current clip that's playing. But you'll also remember that when we first issue a play command, we actually set the duration to 0, and that's so that we can use this little conditional down here in 2 instances. So this is going to be triggered not only if we have a clip assigned to a layer and the time has been incremented past the duration of the clip, but because when we create a new play request for a layer, the duration is set to 0, and we've incremented layer time up here by time.delta time, it also means this will be true when we've just issued a play request for a layer, because layer time will be basically time.delta time, and layer duration will be 0. So we're going to step into this conditional if either the clip assigned to this layer has reached its end, or if we've just made a new play request, in which case we haven't even got a clip assigned yet. Okay, so inside this conditional, we need to know, first of all, if this is a looping layer. If it's a looping layer, then it's time to assign another clip. If it's not a looping layer, then you'll see in a moment, we deactivate the layer. However, we don't just step into this code when the looping boolean is true, because we also need to make a clip assignment to a layer when we first issue a play request, when the clip is null, remember? When we go up to the play function, you can see that we set the clip to null. So inside this conditional, we know we need to fetch a clip from the layer's assigned audio collection and bank and assign it to the layer's clip property. So I need to access the audio collection that has been assigned to our layer, and using that array indexer property, we pass in the bank that we wish it to use, which of course is also stored in our layers bank property. And we know that this here will return an audio clip from this bank in this collection, which we assign to this local audio clip variable called clip. Next up, I check if the clip that we've been returned is the same as the clip that the layer was previously playing. If it was, then instead of just resetting the time to 0, which I would normally do for a new clip, I set the layer time to layer.time modded with layer.clip.length. What I'm basically doing here is just making sure that, let's say for example, delta time was a really big value, like half a second, right? And let's say that we're playing a clip called Gary clip, and we reach the end of Gary clip, and then when layer time is incremented, we select another clip, and it just so happens that the same clip, the Gary clip, gets returned. Now, in order for that to play smoothly, we don't want to reset the time of this clip back to 0, because it should actually be half a second into the next iteration of the loop. I mean, it's a bit of an extreme example, but that's what we're basically doing. We're just making sure that the time that we've added onto layer time is wrapped around the length of the audio clip that we're playing so that we get seamless looping. However, if the clip that we've had returned is not the same as the one that was playing before, then it doesn't really matter. We'll just set layer time to 0 and start playing that clip from the beginning. And we'll get the length of this audio clip and we'll store that in our layers duration member. And we'll also store now that clip in our layers clip member as well. So our layer has now been given a clip, a duration, and the layer time has been reset. It's now already a fully functional layer that will be updated each time, and whenever the layer time exceeds the clip duration, it will assign it a new clip. But of course, we're only assigning clips to the layer. We're not actually assigning the clip yet to the audio source. We're only going to do that for the layer that has the highest layer index. Okay, so next up, we want to know whether this layer that we're currently processing should be the new active layer. Is it the highest layer that we've found so far that should be playing an audio collection? Now remember, at the top of this function, we have this integer called new active layer, which is set to -1 at the beginning. But we also process our layers list in reverse order. So what we're going to do is, as soon as we find the first layer that has an audio collection assigned to it, we know, because we're iterating the loop in reverse order, that this must be the new active layer. And we'll set new active layer to that loop index. But of course, we need to go on processing all of the layers, even the ones that are underneath that and inactive, because we still want to update their layer times and assign new clips if their layer times exceed their clip durations. If the new active layer that we've currently found is smaller than this layer index, well then we know that this must be the new active layer. So what we'll do is we'll set new active layer to I, this layer, and we'll set the refresh audio source boolean to true. Now that means later on when we exit this loop, we're going to know that we've assigned a new clip to our layer, and therefore that clip, because this is the new active layer, should also be assigned to our audio source. However, we have the else case to deal with. Remember, all of this happens if the layer's time has been incremented past the layer duration, which is the duration of the clip currently assigned to it. And we only step into this bit if it's a looping layer or if our clip is null, which means it's a new play request. So in the else clause, we need to handle the case where the layer time has exceeded the duration of the clip, but this isn't a looping layer, in which case we wish to deactivate the layer. And you see, to do that, we simply set layer clip to null, we set layer collection to null, we set layer duration to 0, layer bank to 0, layer looping to false, and layer time to 0. And that is how we deactivate a layer. Because we saw earlier in the function, inside this loop, we say if layer collection equals null, then skip this layer, and that layer will never be processed again. However, we also have to implement the outer else clause, which is the alternative to when our layer time has been incremented and it hasn't exceeded the duration of the clip assigned to it. This is an active layer, and although we incremented the layer time, it hasn't exceeded the duration of the clip currently assigned to it. So inside this else clause, we know we're dealing with a layer that is happily playing. Now when I say playing, I don't mean in the audible sense where it's necessarily assigned to the audio source. What I mean though is it has an audio collection, it has an audio clip, and as far as our layering system is concerned, it's an active layer that is having its time updated with each update. So we need to just check that this layer that we found isn't the highest active layer we found so far. So we say if this layer index, I, is larger than the new active layer that we found so far, well then we make the new active layer equalize. So we now say this is the highest layer that has been found. And that's the end of that layers loop. We iterate through them all in reverse order, updating their times, and if the time exceeds the duration, we either assign a new clip if it's a looping layer, deactivate the layer if it's not a looping layer, or in the case where the time hasn't exceeded the duration of the clip assigned to this layer, we simply check if this layer is currently the highest active layer we found. Okay, so outside this loop, we need to see if the layer has changed or if we need to refresh the audio clip of our audio source. So I say if new active layer doesn't equal active layer, in other words, this update has seen a change in what we consider to be the active layer, which would mean that the clip currently assigned to our audio source is out of date. Or if refresh audio source boolean is set to true, which remember gets set up here when we assign a new clip to the audio source. But then we first check that new active layer doesn't equal -1, because if it does equal -1, then it means we've been able to find any active layer, in which case there's literally nothing to play at all. So we just call the audio source's stop function, we set its clip to null. But if that's not the case, then it means we do have a valid new active layer. So we will fetch that layer from our audio layers list, and we will assign the clip that has been assigned to that layer to our audio source's clip property. We will also fetch the volume from the layer's audio collection and assign that as the volume of our audio source. Notice here though that we do one of those conditionals where we say if this layer is supposed to be muted, if its muted boolean is set to true, then we'll just set the volume of the audio source to 0. Otherwise we'll set it to the volume fetched from the collection. We'll also assign to the audio source's spatial blend property the spatial blend of the audio collection. And we'll also fetch our layer time and we'll assign that as the audio source's time. And this line here is really what makes the whole audio source layered system work, right? Because if we imagine that initially layer 1 was active and its layer time might have been 5 seconds into it, and then layer 2 becomes active for maybe another 5 seconds, well then when it's time to switch back to layer 1 again, layer 1's time would now be 10 seconds, and then when we assign layer 1's audio clip back to the audio source, we can tell the audio source to start playing that sound again from 10 seconds in. And that's how we get the audio clips assigned to each layer to seem as if they are continuously playing, even when they don't have the focus of the audio source. Next up, we always assign to the audio source's loop property a value of false. We're never actually using a looping audio source. When a layer is set to loop, we handle the looping ourselves by saying when the duration has been reached, then fetch another clip from its audio collection. And basically that will get assigned right here in this code that we're writing. So we're never actually looping an audio clip, we're looping an audio collection, but that's all being handled internally by our code. Finally, with our audio source all set up with all the properties it needs, we tell it to play the audio clip. And then at the bottom of the function, we store that new active layer that we may have found in this invocation of the update function and store that in our active layer class variable so that in the next update, we now know what the layer is and we can detect if there's another change again there. Finally, we need to handle the case where a layer is being muted or unmuted. But hang on a minute, didn't we just handle that up here when we assigned a value to our audio source? Well, no, not really, because this code only gets executed when the active layer has changed and we set the volume to what the current muted status of that layer is. But of course, the update function is going to be getting called every frame. So it might be that the active layer hasn't changed and we're 5 seconds into a 20-second audio clip that's playing, and then we decide to mute it. Well, this code wouldn't get executed. It would only get executed the next time a clip needs to be assigned. So what we need to do at the bottom of the function is check every frame that if we do have an active layer and we do have a valid reference to an audio source, then we need to fetch the active layer and we need to check if that layer should be muted. And if the layer that is currently active should be muted, then we just make sure that we set the volume of our audio source to 0. Otherwise, we set the volume of the audio source to the volume property of our audio collection. And that, my friends, if I'm not mistaken, is our layered audio source complete. Okay, so let's go back to the editor and check we haven't got any errors, which we haven't. So what I need to do now is make sure that my zombies have an audio source that our layered audio source class can manage. We want this audio source to be on the AI entity game object of each of our zombies. That's the same object that has our AI state machine script on. So I'm going to open up all of my zombie hierarchies. Then I'm going to select each of those AI entity game objects. And from the Add Component menu, I'm going to choose to add a new audio source. And I'll just untick where it says Play on Awake. And I'm also going to assign the output of each of these audio sources to the Zombies group on the audio mixer. What I do need to do now is I need to save those changes back to the prefab for each zombie. And I can't do this using a multi-select, so I'm going to have to select each one and hit the apply button in the inspector of the parent game object. Okay, so now that our zombies have their audio sources, what we need to do is configure our state machine to be able to use it. Now, the way that's going to work is in the startup procedure of our AI state machine, we're going to allocate a new layered audio source, and we're going to tell that layered audio source object to manage the audio source component that we've just added to its game object. We'll then add a few public functions to our AI state machines so that state machine behaviors in our animator can make requests to play a sound using the AI state machine's underlying layered audio source. Because the layered audio source has to update its internal properties each frame and update the timelines of each of its layers, that means we need to remember to call its update function each frame as well. Now, there's nothing wrong with that, but let's just say, for example, we're using the layered audio source for some other object that doesn't even need an update function. But then we would find ourselves implementing an update function for no other reason than just to call the update function of the layered audio source. So what I would like to do is create an alternative system that we can use where the audio manager itself will be responsible for creating the layered audio source and updating it. Using this method, all our AI zombie state machine will need to do is say to the audio manager, hey, I want you to create a new layered audio source using this audio source component. And then the audio manager will create that, store it internally in a list of managed layered audio sources, and then our audio manager in its update function will take care of looping through any registered layered audio sources and calling their update functions. So from our AI state machine's perspective, we just have to create it and kind of forget about it. And we just have to worry about making play requests when we want to play a sound on a given layer. Okay, so to do that, I'm going to open up my audio manager script in MonoDevelop. So the first thing we'll add to our list of private variables is going to be a list of layered audio sources, which I've called layered audio. And we'll create some functions in a moment that allow us to register a layered audio source, which will create a new layered audio source object and add it to this list. Now we already have an update stub here, you may remember, just an empty update function. So let's add some code to that. So I'm going to create a for loop that's going to loop through every layered audio source in our layered audio list. And assuming it's not null, we're going to call its update function. So every frame, our audio manager is going to call the update function of every layered audio source that it's currently managing. We're also going to need some functions to register a layered audio source and to unregister a layered audio source. So I'm going to create a function here called register layered audio source. It takes two parameters. The first is the audio source component that we wish it to manage, and the second is the number of layers that we wish the layered audio source that the audio manager is now going to create for us to have. And you see that it actually returns the layered audio source object that it's going to create. So what I will do inside the function is I will say, assuming we haven't been passed a null reference as the audio source, and that the layer count is larger than 0, then we're going to loop through every layered audio source that we've currently got in our internal list and just check that it doesn't already exist. We don't want to create two entries in our list to the same audio source object. So inside the loop, I get the current layered audio source that we're processing, and assuming it's not null, I just see if this already has the same source that we've been passed, all right? So what we're trying to eliminate here is that we don't have two completely separate layered audio source objects that manage the same audio source component, because that would be really weird and the behavior would be undefined. And if it is, we just simply return a reference to that layered audio source that already exists. But assuming that is not the case, and this is a brand new audio source component that we've been passed, which doesn't currently have a layered audio source object defined for it, we create a brand new layered audio source object, passing into the constructor the audio source and the number of layers that was passed into the register layered audio source function. Of course, once this layered audio source object has been created, we add it to our layered audio list, and finally we return a reference to the layered audio source that we've just created and added to our list. So next up, we want to create the ability to unregister a layered audio source. Now this is really important because remember, our audio manager is a don't destroy on load object. This means if we exit one scene and go into another scene, we need any layered audio sources that may have been managing audio sources in the previous scene to be unregistered and removed from the list. Now, when I first created the Creeper demo, I hadn't created the unregister function, and when I decided to add a title screen scene to the game, when I left the main game scene and was transported back to the menu screen, all of the zombies, of course, in the game scene were destroyed and unloaded from memory, along with their audio sources. But because the audio manager is a don't destroy unload object, when I went back to the title screen, I still had this layered audio list in my audio manager that was maintaining references to all those layered audio sources, but of course the actual audio source being managed by all those layered audio sources were no longer in memory. They'd been destroyed. So we need to make sure that any object that has registered a layered audio source also unregisters it when that object is destroyed. Okay, so let's now write the unregistered layered audio source function, which takes as a single parameter a reference to the layered audio source. And this just calls our list's remove function so that our layered audio source is removed from the list. You may be wondering why I'm casting that to a layered audio source. Don't worry, that's not necessary at the moment, but it will be in a moment when I show you what else I've got planned. Okay, so I'm going to create another version of the unregister function where we may not have a reference to the layered audio source, but we may just have the audio source component, the thing that is being managed by the layered audio source. So I don't know if I use this, but it seems like it would be a convenient thing to have. So I call it unregistered layered audio source again. It's an overload, but this time as its single parameter, it takes a reference to an audio source component. Inside, I set up a loop to loop through all of the layered audio sources in our internal list. I get the layered audio source that we're currently processing, and assuming it's not null, I check if the audio source stored in that layered audio source is the same as the source that has been passed in. And if it is, then this is the layered audio source that we wish to remove from the list. So we simply call the list's remove function and return. So if I save that off now, go back to the editor and check I haven't got any errors. I probably have. No, I haven't. Okay, we're nearly there, but there's one thing I don't like about our audio manager setup at the moment. Let's say, for example, I register a layered audio source with the audio manager from my AI zombie state machine. I'm going to get returned to me a layered audio source object. Now, we know that the audio manager is responsible for calling the update function of all of the layered audio sources that it manages. However, it is something that somebody using this class might forget, and we might have a situation where we're also manually calling the update function as well. So not only are we calling the update function on the layered audio source, but so is the audio manager. We're getting a double update and the sound's playing back incorrectly. So what I would like, if possible, is a situation where if we decide not to use the audio manager and we just create a layered audio source ourselves, then of course we are responsible for calling the update function and should be able to do so. But in the case where we've registered a layered audio source with the audio manager, I don't want us to be able to call the update function. I wish to dissuade it as much as possible. So the way I'm going to do that is rather than our registered layered audio source function returning a layered audio source object, it's going to return an iLayered audio source interface. The interface is going to implement all of the public functions except the update function. Now, this is a really useful reminder for people using our audio manager, because if we register a layered audio source, we're going to get back an iLayered audio source interface. And if we try and call the update function on that, it just won't exist. Now, of course, you could cast what you get returned from an iLayered audio source back to just a layered audio source object and then call its update function. But if you want to do that, so be it on your head. We're doing everything we can do by saying, like, what we're returning to you is an interface to this object which doesn't have an update function. So that's our way of saying to you, you really don't want to be calling an update function on this object. So in order to do that, what I'll do is I will change a few lines of code here so that our registered layered audio source doesn't return a layered audio source object, it returns an iLayered audio source instead. And also, the caller, when it wants to unregister the layered audio source, is also going to be passing that in. So the version of the function where we unregister the layered audio source by passing in a reference to the layered audio source, that needs to be a reference to an iLayered audio source. And of course, now you can see why I cast that to the layered audio source, which is what's actually stored in our list. Okay, so that looks like it'll work. What we need now is to define the iLayered audio source interface, because at the moment it does not exist. So I'm going to go up to the top of the file, just above where we define the audio manager, and right here I'm going to define the iLayered audio source interface. Oh, actually, what am I talking about? I don't want to put it here, do I? I want to put it at the top of my layered audio source file. So I've opened up layered audio source.cs and I want to put it up here. That makes much more sense than defining the interface in the audio manager, doesn't it? And I'm just going to paste it in because it's so simple. As you can see, this interface simply implements the play, stop, and the two versions of the mute function, but doesn't define the update function, which means when we return this interface back to the caller won't be able to say iLayeredAudioSource.update, for example. The update function is not defined in this interface, and that's a really good indicator to anyone using the audio manager to manage its layered audio sources that they do not need to call the update. The audio manager would do this for us. Okay, so let me save that off, go back to the editor, check we haven't got any errors. Okay, that's cool. So our next task is to open up our AI zombie state machine. No, sorry, the base class, the AI state machine. And we need to add the code that's going to create a new layered audio source object using the audio manager, and also define some functions such as a play function, a stop function, a mute function, etc. that state machine behaviors in our animator will be able to call when it wishes to play a sound for a given layer using the layered audio source of the AI entity. So I'm going to drill down into the scripts folder, the AI folder, and I'm going to open up the AI state machine script in MonoDevelop. Okay, so here I am in my AI state machine class, and just underneath where we declare all of our serialized protected variables, I'm going to declare a protected variable of type iLayeredAudioSource. Remember, that's our interface, and I've called this layered audio source with an underscore, and I've set this to null. Now what we're going to do in our awake function is we're going to grab the audio source component, which remember we've added to our AI entity game object, so I'll do that underneath where we cache all of the component references, about here I think. And as you can see, I declare a local variable of type audio source, and I use the getComponent function to fetch the audio source that is on this game object. Now that I have the audio source at the bottom of the awake function, I can use our audio manager to register a new layered audio source and get back that iLayered audio source interface. So you can see I do a conditional to check first of all that I have a valid reference to an animator, I have a valid reference to an audio source component, and we have an audio manager instance in the scene. And assuming all of these conditions are met, you can see I call the audio manager's register layered audio source function. Remember, this takes two parameters. The first is the audio source that we would like the layered audio source object to manage, which is our audio source component, which we just grabbed at the top of the function here. Remember, this is the audio source component that is on our AI entity game object. And as the second parameter, I need to pass in how many layers we want to create for this layered audio source. That needs to match the number of layers in our animator. So we just use our animator's layer count property. And of course, we've already seen that the audio manager will create a layered audio source object, add that to its internal list of managed layered audio source objects, and return to us an iLayered audio source interface, which we store in our class variable here. So if I scroll just above the awake function, you can see that we have those functions that we created, I think it was in the last lesson, that is used by our state machine behaviors to set the active layer and to check if a layer is active. So we want to take some additional action now in the set layer active function. At the moment, it simply sets the boolean of our anim layers active dictionary to either true or false. But what we want to do is also say that if we have chosen to deactivate a layer by passing in false as the active parameter, and we do have a valid iLayered audio source object, well then we're going to call the layered audio source's stop function, passing in the layer index that we wish to stop the sound playing on. In other words, which layer we wish to deactivate. Now, we're passed into this function the name of the layer, but we actually want the index of the layer to pass into our stop function. So what we do is we use the animator's getLayerIndex, passing in the name of the layer that we've requested to be stopped. And of course, the animator's getLayerIndex function will return the index of that layer, which we pass into our stop function. And of course, we've seen within the layered audio source class that when we issue this stop command, what that's going to do is in the next update function, the layered audio source is going to deactivate that layer, and one of the other layers will become active and will commandeer the audio source. Of course, if no other layers are active, then the sound will just simply stop playing and there will be nothing assigned to our audio source. So all we're saying here is that when we deactivate a layer in our state machine, we also want the corresponding layer in our layered audio source to stop playing as well. So next up, we need to create some public functions that state machine behaviors in our animator can call when they wish to instruct our AI state machine to play a sound using its layered audio source. So the first function we'll create is a public function called play audio. It returns a bool indicating whether the request was successful or not. And as we would expect, it takes a number of parameters: the audio collection to use, the bank in that audio collection to sample a sound from, the integer layer that we would like to use when playing this sound in our layered audio source, and whether the layer should be looping while playing this collection. And inside the function, we'll just make sure we have a valid reference to an I layered audio source interface, and if not, we will return false. Otherwise, we will call the layered audio sources play function, passing in the audio collection, the bank, the layer, and whether it should be looping or not. And the layered audio sources play function returns true or false whether the request was successful, so we simply return that from our play function as well. Next up, we'll create a stop function, which I'll call stop audio, and all this takes is the integer layer of the layer in our layered audio source that we would like to stop playing the collection on. And as you can see inside, I check we have a valid reference to an I layered audio source interface, and if we do, I call the layered audio source's stop function, passing in the index of the layer that we would like to deactivate in our layered audio source. And next up, I'm going to create a mute audio function, which can be used to simply mute all of the layers in our audio source. So as you can see, it takes a single parameter, a boolean, describing whether we wish to mute or unmute the audio source, and assuming we have a valid reference to an I layered audio source interface, we call its mute function, passing in either true or false whether we wish to mute all the layers or unmute all the layers in our layered audio source. Now, I could create another version, an overload of the mute audio function, because you will remember that in our layered audio source we also have the ability to mute a single layer, but I didn't use that in Creeper, so I'm not going to implement it yet. If we do need it further on down the line, we can always add that here. So these three functions that we've just added essentially provide the API to our state machine behaviors that it can use to tell the AI state machine to play sounds or stop playing sounds in response to certain states changing in our animator. And in a minute, we're going to write a new state machine behavior that can be used to call these functions and do just that. But the last function we need to add to this class, I'm going to scroll right to the very bottom, and you will remember that I said a few moments ago that any object that uses the audio manager's register layer audio source function should also unregister that same audio source when the object is destroyed. So what we will do in our AI state machine right at the very bottom is we will implement one of Unity's functions called onDestroy. And this is a function that will be called by the Unity engine when our AI state machine component is destroyed. And inside, we'll check we have a valid reference to a layered audio source and that we also have an audio manager instance in the scene. And assuming that's the case, which it always should be, we call the audio manager's unregister layered audio source function, passing in the I layered audio source interface that we were originally given by the audio manager when we first registered the sound. And this is going to make sure that when this object is destroyed, that the layered audio source in the audio manager that corresponds to this object is also removed from its internal list of managed audio sources, and we won't have any broken references when we load into another scene. Okay, so I think that's pretty much everything. Let me go back to the editor, check I haven't got any errors. And I seem to have an error here. 2 errors, in fact. Oh, it's complaining that it can't convert layered audio source to I-layered audio source here without an explicit cast. It's really... Oh, I know what I might... Oh, I think I know what I've done. Oh, what an idiot. Okay, so this is what I did. So after I declared my I-layered audio source interface, I actually forgot to declare this interface as being supported by our layered audio source class. So of course I need to derive layered audio source from I-layered audio source. Like so. What a dickhead. Okay, that should have got rid of the errors. There you go. Okay, so we've written a lot of code, but we don't know if any of it works yet. So what we need to do now is create a state machine behavior, which I'll call AI layered audio source player. And that's going to be a state machine behavior that we can add to states in our animator. And that script is going to make requests to the play and stop functions that we've just added to our AI state machine to issue play and stop requests to its underlying layered audio source, which of course is going to be managed by the audio manager in the scene. So let's do that now. So I'm going to drill down into the scripts folder, the AI folder, and the state machine behaviors folder, and I'm going to create a new C# script, and I'm going to call this AI layered audio source player. Wow, that's a mouthful, isn't it? I don't just want to call it layered audio source player because this particular script is very specific for dealing with the interface that is exposed by an AI state machine. So later on down the line, we might want to create other state machine behaviors that also handle layered audio sources on other objects. So this is specifically a script that is added to our AI entities when we wish to issue play or stop requests to a given layer in its layered audio source. So I'm now going to open up the AI layered audio source player in MonoDevelop. This is not going to be a mono behavior, it's going to be a state machine behavior. So I'm going to get rid of the start and update functions. I'm going to put the curly brace on the next line. And instead of deriving from mono behavior, we're going to derive from our base state machine behavior class, which is AI state machine link. You remember that's the one that will always have a reference and a link to the state machine that this animator belongs to. So this state machine behavior is going to need some variables that we can assign via the inspector. The first one is an audio collection that I call collection with an underscore. This will allow us to assign any of our audio collections to an instance of this script, informing it which collection should be played. The second inspector assigned variable is where we get to tell it the bank within the assigned collection that we would like it to use. Next up, we have a boolean where we can choose whether we wish this to be a looping sound or just played once. Most of the time we'll be using looping sounds, but in the case of, for example, the interactive layer, when our zombie is screaming, we won't want the scream sound to loop, we will only want it to play once and then the layer be deactivated, irrespective of whether we are still in the screaming state. And the final inspector variable is a boolean which I call stop on exit, which will allow us to configure the script to tell it whether we wish it to actually stop playing the sound when the state exits, or whether we just wish it to leave that sound playing. We're also going to need a private variable because we're going to need to keep track of the current weight of the layer that this script has been assigned to, because obviously if a layer has a weight of 0, it's completely inactive and therefore its sound shouldn't play either. And because the layer weight can change from one frame to the next, we need to keep track in the update of this script. Every frame we need to see if the layer weight has changed and if it has, possibly stop the sound from playing, or start it from playing if it's just become active. So first of all, we'll create the onEnter function, which is called by Unity when the state that this script is assigned to is first entered. First of all, we'll check we have a valid reference to a state machine. If we don't, we simply return. There's nothing we can do. Next up, we'll fetch the layer weight from the animator, and assuming we've been assigned a valid collection, and assuming the layer weight is larger than 0.5. Now, in my system, an active layer always has a weight of 1. Okay, so I use 0.5 as a threshold here, but you could change this to like 0.01 or if just larger than 0. And you'll also see that in this condition, I also say if layer index equals 0, or if the layer weight is larger than 0.5, because the base layer essentially doesn't have a layer weight. So that's why we say if the layer index is 0, or if the layer weight is larger than 0.5, then we have an active layer. In which case, we contact our state machine and we use that play audio function we just implemented, passing in the collection, the bank, the layer index, and whether we wish the collection to be looping or not. Otherwise, the layer weight is 0, in which case we call the state machine stop audio function to stop the audio playing on that layer. And finally, at the bottom of the onStateEnter function, we just make sure that we assign to previous layer weight the current layer weight, so we can track changes on a frame-by-frame basis. Next up, we're going to create the onStateUpdated function, which is going to be called every frame by Unity while this animation state is active. Once again, at the top of this function, we'll just check that the state machine isn't null. If it is, then we return. There's nothing we can do. We also fetch the layer weight from the animator, and if the layer weight is changed, and of course we don't have a null collection, we need to check whether the layer has become active from being inactive, or has become inactive from previously being active. So we say if layer weight is larger than 0.5, then play the audio collection and the bank that we've assigned it. Otherwise, stop the audio on this layer. And finally, at the bottom of the function, we assign to previous layer weight the current layer weight. Finally, we create the onStateExit function, which is called by Unity when we exit this animation state. As you can see, if we have a valid reference to a state machine and we have set the stop on exit boolean to true, then that means that we actually wish to forcibly stop the layer from playing in our layered audio source when we exit this current state. So you can see I say if state machine isn't null, and the stop on exit boolean is true, then call our state machine stop audio function, passing in this layer's index. And that is our AI layered audio source player complete. Now I know I went through that pretty quickly, but there's not really anything here that we haven't done before. Okay then, so looking at the time, I should really think about bringing this lesson to an end. However, I don't want to end without having used any of the code that we've written in this lesson. So I think what we'll do is we'll set up a few of the state machine behaviors on Jill's animator. Maybe we'll just set up the layered audio source scripts to play on her base layer and lower body layer for now. And then when we come back in the next lesson, we will finally go through all of the other layers, and then we'll have a fully completed zombie sound system, which we can then clone into the rest of our zombies. So the next lesson is going to be nice and easy and quite uncodey, because we're really just going to be creating audio collections and assigning scripts to animation states. Okay, so the first thing I'm going to do then is I'm going to create a roaming audio collection. Now, when I say roaming, I'm talking about a collection that contains all of the sounds that the zombie is going to make when it's just walking around the level in a non-agitated state. So I'm going to drill down into my sounds folder and into my audio collections folder. I'm going to go to the assets menu, and I'm going to create a brand new audio collection, and I'm going to call this zombie roaming, like so. Okay, so next, with the zombie roaming audio collection selected, I'm going to lock its inspector so that when I go hunting for sounds in a minute in the project window, I don't lose the focus. Oh, before I do that though, let's make sure that we assign our zombie roaming audio collection to the correct audio mixer group, which is zombies. For now, I'm going to leave the volume of this audio collection at its maximum of 1. This audio collection is only going to have one bank, which contains all of the zombie roaming sounds. If I drill down now in my sounds folder and into the zombie sounds folder, you'll see there's a folder called ambient. And in there, we have a series of roaming sounds. I'm going to multi-select them all, and then I'm going to drag and drop them onto the clips property of the zombie roaming audio collections inspector. And there you go, I can now unlock the inspector. So with all of the zombie roaming sounds selected, I'm just going to tick force to mono just in case I've accidentally imported any stereo sounds when I was recording it. And I think I'm going to set these to PCM uncompressed again. They're quite long sounds these, but it's not like our application is going to be taxing any modern PC for memory, so I think we can afford it. And just to remind you what these kind of things sound like, here's one of the roaming sounds. Here's another one. And here's another one. Those are probably quite loud, so let me turn them down. Okay, so with Zombie Jill's animator and her base layer selected, I'm going to select her idle state, and I'm going to add to that an AI layered audio source player. Then I'm going to make sure that I assign to that collection that new zombie roaming audio collection that we just created. I'm going to leave bank at 0. I'm also going to set looping to true. We want this audio collection to continue playing indefinitely while our zombie is in the idle state. But I'm not going to select stop on exit. We don't want to forcibly stop this collection from playing when we exit the idle state. You see, if we go from the idle state into the walk state, we want this collection to carry on playing without any seams between them. So we don't want to stop it and then restart it. We want it just to carry on playing. However, we don't have to worry about it transitioning into, say, a turn left or turn right state where we're going to want to play an alerted collection, because as soon as we make the play request on that state, well, that's going to assign a new audio collection to that layer in the layered audio source, and it will automatically override what was playing anyway. Now I'm going to select my walk state, and I'm also going to add an AI layered audio source player script to that, and assign it the same zombie roaming audio collection. Once again, leaving all the properties the same, bank 0, looping true, stop on exit equals false. Before pressing play to test if this works, I'm just going to check that Jill has been set up so that we're going to use the walking and the idle states in our base layer. So let me just check I have set idle. Yeah, I've set idle to 10 seconds, and I've set patrol to speed 1, so it's going to use the walking state. I'm also, for now, going to select my FPS controller rig, and I'm going to disable the sound emitter, just so that we don't alert the zombie as we drop into the level, or we can walk around and walk up behind the zombie without alerting her. Actually, having just done a test run there while this was paused, I've changed my mind so that we can better hear the sounds while we're looking at it in the scene view, because I don't want to have to keep following Jill around with the FPS controller. what I'm going to do is I'm just going to temporarily alter the properties of the footsteps and the roaming audio collections so that they become sort of two-dimensional, so that they don't attenuate with distance. So I'm going to select my audio collections folder. I'm going to select my zombie footsteps audio collection first. I'm going to put the volume down to about 0.2, which is where it was anyway, but I'm going to set spatial blend down to 0, okay? So we're not going to get any 3D positioning. And I'm going to do exactly the same for my roaming audio collection as well. So I'm going to put the volume down to somewhere, 0. Probably a bit louder, maybe 0.3, but spatial blend down to 0, so it's a two-dimensional sound for now, okay? And now when I press play, we should hear something in the scene view. I'm not worried about the game view for now. And when she walks, we should hear a seamless continuation of the roaming sound. Okay, so what we want to do now is we want to set up some of her other sounds, because at the moment, when she goes into the turn left or turn right, when she reaches her first waypoint, we know that we have Jill going into a very alerted animation. So we want to create an alerted audio collection for that as well. Because at the moment, we're not stopping the roaming audio collection when we leave idle. So what would happen is that roaming audio collection would just carry on playing here. So now we're going to create the alerted audio collection. I think while we're at it, we'll also create the jogging audio collection, which is going to be used by these two states as well. And then we'll have the complete kind of base layer, base locomotion done. Okay, so with my audio collections folder selected, I'm going to go to the assets menu, the create submenu, choose to create a new audio collection. I'm going to call this zombie alerted, like so. With my zombie alerted audio collection selected, I'm going to configure the inspector so that we assign it to the zombies audio group. And for now, I'm going to set the volume down to roughly what we had our roaming set to, which was about 0.3. And I'm going to set the spatial blend so it's a two-dimensional sound, just so we can hear it better while viewing in the scene view. Also, this needs to have only one bank of sounds. And let's now lock the inspector of the zombie alerted audio collection so I can now start searching for the sounds I want to use without losing the focus. So I'm going to go into my zombie sounds folder, in my ambient folder, and you can see I have two audio clips in here, Zombie Alerted 1 and Zombie Alerted 2. Now, I know in Creeper I only used Zombie Alerted 1. Can't remember why, but I'm going to do the same here. So I'm just going to drag Zombie Alerted 1, drop it in the clips, and what we have here is a Zombie Alerted audio collection with just a single clip in it. I'm going to unlock the inspector, select the Zombie Alerted clip, and then press play. Yeah, that's the sound we're going to play when she's turning on the spot in a very agitated animation. But you can see I've brought this in stereo, so let's set this to mono. Let's also set this to be PCM. Click apply, and now we're good to start setting up our zombie turn left and zombie turn right states in Jill's base layer. So I'm going to select zombie turn left first of all. I'm going to add a new AI layered audio source player, and I'm going to assign that the alerted audio collection. And it's going to be set up exactly the same. We wish this sound to continue looping for however long Jill may be seeking left or right. And I'm going to do, of course, exactly the same for the zombie turn right state. So I select the zombie turn right animation. I add a new AI layered audio source player script, and I assign to that the zombie alerted audio collection. Now we're going to create the audio collection that's going to be used by our zombie jog and our zombie sprint. You'll notice in our Zombie Sounds ambient folder, we have two audio clips here called Zombie Run 1 and Zombie Run 2. And here's Zombie Run 2. Now, I've got a feeling, I don't know why, maybe it was through testing, but in Creeper, I only used Zombie Run 1. I just thought it sounded better with this one repeating, because it's quite a long sound anyway, so you don't hear any obvious repeats. And Zombie Run 2 had a few bits in it I didn't like, so I decided not to use it in the end. Okay, so let's create an audio collection now called Zombie Run, which has our Zombie Run 1 audio clip in it. So I'm going to select my audio collections folder, go to the assets menu, the create submenu, choose to create a new audio collection, which I'm going to call Zombie Run, like so. I'm going to assign this to the zombies audio group. Assign the sound down to about 0.3, which is the rough volume of the other sounds our zombie is making. And for now, just set the spatial blend down to 0 so that we can hear it. This is also going to have a single bank, and then I'm going to lock the inspector, select my ambient folder, find that zombie run one clip, drag and drop that onto the clips property of our one and only bank in our zombie run audio collection. Then I'm going to unlock its inspector, select zombie 1, and you can see this has come in as a stereo sound also, because these were all recorded by me, and by default I think my recording software just always records it in stereo unless I remember to record it in mono. So we're going to force this to mono, going to set it to PCM, and we're going to hit apply. Now we're going to select Zombie Jill's zombie jog state, add an AI layered audio source player, and assign it the zombie run audio collection. Once again, needs to be looping. We want this to play for as long as our zombie is jogging. Once again, we don't want to select stop on exit, because when we transition from zombie jog into zombie sprint, we want that audio collection to continue playing seamlessly, so we don't want to restart it again. Also, I'm going to do exactly the same now for my zombie sprint state. Assign it a new AI layered audio source player, and assign to the collection property of that player script the zombie run audio collection, leaving looping set to true by default. Okay, so let's press play now and see what happens. We're probably not going to see the jog or sprint yet, but we should see Jill move to her first waypoint, enter an alerted state. Actually, what am I talking about? I can show all of this very quickly by enabling my sound emitter on my FPS controller, and then shining my torch on Jill so that she sort of turns around to see me. You can hear her breathing when she comes after me. I need to get away from her now. You can hear her alerted sound there, look. Now she's come out of the alerted state and she's just started walking around the... Oh God, she saw me. Oh, so I know why she's being so so persistent. It's because while I was testing, I set her visual field of view to something really high. Look, 314 degrees. So let's put that. That means she's literally got eyes in the back of her head. That's something you can do actually if you want to make the zombies a lot more challenging. You can give them a really unrealistic field of view, and sometimes that can make them seem really relentless. Okay, so what we'll do now is we'll watch Jill go to her first waypoint, and then she should enter the alerted state. I mean, we did hear her alerted sounds playing then, but because I was hiding from her like a great big yellow coward, we couldn't actually see it syncing up with the movement. But we did get to hear her sprinting, and that sounded pretty good with her going... Come on, Jill, hurry up and get there. Yeah, so that worked perfectly. Good. Okay, so we've got the basic locomotion on a base layer working. Let's now set up the locomotion for the damaged layer, which I don't think we even need to create any more audio collections. We just want to set them differently. So I'm going to call up Jill's animator, and this time I'm going to go to her lower body layer. And on the idle state, I'm going to add an AI layered audio source group. And I'm going to add to that the zombie roaming audio collection. I'm going to do exactly the same for her walk state, assigning it the zombie roaming audio collection. Now, when she is turning left and right in the damaged lower body layer, she does a very laboured sort of dragging her body round. So we don't want that alerted sound. In fact, we actually want the same roaming audio to be used for the turn left and turn right state as well. So once again, I'm going to assign an AI layered audio source player script. I'm going to assign to that the zombie roaming, and then I'm going to do exactly the same on the zombie turn right state as well. Now I'm going to have to remind myself of some of these animations on the lower body layer. Can't remember what they're like. Yeah, so when she's walking, we'll just have the standard zombie roaming sound. Now, the zombie jog state in the damage layer kind of looks like that. So I think for that one, we still want the zombie roaming sounds playing. We still want her going... So we're going to add another pretty much exact duplicate of what we've done on all the other states on the lower body layer. Give her the zombie roaming audio collection. And let's have a look at the sprint. Well, that's a slightly faster animation, so I think for that we will give her the panty, you know, so we will give her the zombie run audio collection. So finally, I'm going to add a new AI layered audio source. I'm going to assign to that the zombie run audio collection. So what I need to do now is select Jill's AI entity, and I need to configure her so that she is damaged when we press play. So I need to put a lower body up to about 40. What's the lower body threshold? Yeah, that should be fine. Limp threshold is 30, so I've set it to 40. Okay, so let's see Jill in action. Now she's damaged. Where's she gone? Oops, it looks like my idle animation on that layer is not a looping one. So when she reaches her first waypoint and she starts seeking left and right, because she's using that really kind of laboured turn, we don't want her to play that alerted sound. We just want her to play that sort of what sound's playing now, the roaming sounds. And this is a really good example of the layered audio source working exactly as it should, because of course the base layer is telling our layered audio source to play a completely different set of sounds. And those requests are being overwritten by our layered audio source, because the layer above it now, the lower body layer, is giving it a different request and taking precedence. So here we go. So when she turns now, yeah, perfect. You can see it just carried on playing the roaming sounds. Okay, so what we've set up so far works perfectly. We just need to come back in the next lesson and really just add all of the various scripts to all of the animation states on all of the layers of Jill's animator, and then reflect those changes across all of our zombies. So, like I said, next lesson is going to be pretty light from a coding perspective, but we're just going to be like configuring Jill, and hopefully by the end of the next lesson, I know I've probably said this a few times already, the zombie sound system should be done. Okay, so before I finish up this video, there's two things that I want to fix that I noticed while we were testing this. The first one, of course, is the idle animation on Jill's lower body layer. This animation only went on for 7 seconds, and Jill was currently configured to stay in idle for 10 seconds. And what we saw just briefly for 3 seconds was the animation wasn't set to loop, so it reached the end of its cycle, and Jill just stood there completely frozen for 3 seconds until the idle animation was exited. So this is going to vary depending on which animation you've got assigned to your idle state on Jill's lower body layer, but if it's the same as mine, it's one of those pre-baked animations again. So I just double click it to select it, and I just enable loop time, and that should see Jill's idle animation on the lower body layer seamlessly loop, and that's the first problem solved. Okay, that seems to work. Okay, the second problem we've got really is one of consistency. You will remember that Jill, when we gave her her own audio source that was going to be managed by her layered audio source class, we manually assigned her audio source to the zombies audio mixer group. And we can test this is working fine by pressing play and having the audio mixer tab open, and we can see that the zombie sounds are indeed being made on the zombies channel. However, this isn't consistent with the way that we've set things up in the past. Usually, we take the audio mixer group from the audio collection. So, for example, we know that on Jill's base layer or lower body layer, each audio collection that we've assigned her has been assigned to the zombies audio mixer group. But if I select Jill's AI entity game object and let's say set the audio mixer group of her audio source to say scene instead of zombies, well then when I press play and call up the audio mixer tab, you can see that all of those sounds being made by Jill's layered audio source are actually being made on the wrong channel, the scenes channel, because that's the one that we've manually assigned to Jill's audio source. Now, of course, you might say, well, yeah, what do you expect? You manually assigned it the scene audio mixer group, and therefore you're silly for doing that. But I don't want to have to remember to have to assign this. I would much rather just leave this at none and allow my audio system to automatically set the audio mixer group based on the audio collection that is currently playing. Firstly, this means it's something else I'd have to worry about configuring, but secondly, it gives us much more flexibility. We may very well in the future want to have a situation where when we transition from one state to another, we play a different audio collection on each state. And those audio collections may be configured to play through different audio mixer groups. And at the moment, it doesn't allow us that flexibility. So all we need to do is in our layered audio source class, when we assign all of those properties, whenever there's been a clip change, we just need to fetch the audio mixer group from the audio collection that's assigned to the active layer and assign that to the audio source as well. And that will solve all of our problems. Now, just to remind you, if I open up the audio manager script in MonoDevelop, if I scroll down, you'll remember that we wrote this function here, which I'm not even sure we've ever used yet, called getAudioGroup from track name. We pass in a string, which is the name of the audio mixer group, which we can fetch from our audio collection. And this function will actually return the audio mixer group asset, which then we can assign to the audio clip. So that's really easy to fix. We just open up our layered audio source class, scroll down to the update function, and at the bottom of the function, we have this little block of code here where all of the assignments are made to the audio source when there's been a clip change. And all we need to do is add a new line of code here. So you can see I set the audio sources output audio mixer group property, which is expecting an audio mixer group object. And to get that, I call the audio manager's get audio group from track name function, passing in the audio group string that was assigned to the audio collection assigned to this currently active layer. If I save that off, go back to the editor, and select Jill's AI entity, and just remind you that when we press play, there is now no audio mixer group assigned to the layered audio source. When I press play, this should automatically happen because now it's being taken from whatever audio collection is currently playing. I'm going to press play, and we can see straight away, looking in Jill's inspector, that we've automatically had assigned to the audio mixer group the zombies audio mixer group, and we can also see by checking in the audio mixer that this is working as well. And like I said, this gives us lots of flexibility because it means that we could have different layered audio source player scripts on different animation states that use collections that are assigned to different audio mixer groups. Okay, before I go, one more thing I want to talk about, and that is our mute system. You'll remember when we created the layered audio source, we also had the ability to mute layers. Now, at the moment, I've implemented that in a very specific type of way, and I don't even know whether that's the right way. I'm probably not going to know till further on during the development of Dead Earth when I actually need to use the mute system, because I've never used it yet. But the way it works at the moment is if, let's say, for example, we have two layers that are currently playing sounds, layer 1 and layer 2. Now we know that layer 2 would currently be the active layer and the layer that is currently having its audio collection played. Now if we mute layer 2, what currently happens, because it's the active layer, is we actually mute the audio source. Now I think that's the way we want it to work, but we may decide further on down the line that when we mute layer 2, we don't want the audio source to stop making sounds. We just want layer 1 underneath to start playing, much like what happens when we stop layer 2 and then layer 1 becomes the active layer. Now this is very easy to implement if we decide we want to do it. If I open up my layered audio source script and scroll down to the update function, we really just need to add a few little conditional checks whenever we're checking for the new active layer if we wish to implement it the other way. In this layer of code here, where we're trying to decide whether we've selected a new clip, we say if this is the new active layer, in other words, if layer I is larger than the new active layer we found so far, then we would say, and if layer I isn't muted. We would do that here, and we would do it down here as well, where once again, if there hasn't been a change of clip, but we're just trying to see if a new layer has become active, then we would say if I is the new layer and I is not muted, then make this the new active layer. If we add those two additional conditional checks in both these places, then what that would do is it would say when we mute a layer, it would no longer be the active layer, therefore another layer underneath it would start playing instead, but the layer we've muted would still continue to have its time updated. And we may need to make that change further on down the road, I don't know yet. But like I said, at the moment, the mute system has been set up to work such that when we mute the currently active layer, the audio source doesn't make a sound anymore. It has its volume set to 0. You remember down here? We say if we've got an active layer and the active layer is muted, then we set the volume of the audio source to 0. Otherwise, we take the volume from the audio collection. So that's just something to bear in mind going forward if we find the mute system as I've developed it at the moment doesn't fit our needs. Okay, guys and girls, I hope you enjoyed this lesson. I will see you in the next video. Bye-bye now.